This is page 10 of the Exponential and Logarithmic Review lessons for the Math 30-2 diploma. Let's continue on example number 10. We were problem solving with exponentials and logs. Example 10 says a car depreciates by 15% per year. It is currently valued at $7,500. How long will it take before the car is worth $2,000? Let's see if we can start with our general form of the equation, y equals a times b to the power of t over p, and fill in what we know. So we know a is the initial amount. So it says it is currently valued at 7,500. Y is the final amount, which is $2,000. So we know that it is going down in price. We also know that because the question said that it is depreciating. Depreciating means going down by 5% per year. Okay, my B value. If I go back in the notes, remember that there were 4 different options for my B value right here. So because this is a decreasing question, we're going to take 1 and we are going to subtract the rate of decrease as a decimal. So 1 minus 15% as a decimal is 0.15. Take 15 and divide it by 100. So that's going to be my B value. That's going to be 0.85. Okay, and then T is what we're looking for. We're looking for the amount of time. And then P for these types of questions is typically going to be 1. We pull that from the fact that it says per year. So we can actually ignore that. So when I simplify my equation, I'm going to get 2,000 equals 7,500. 1 minus 0.15 is 0.85, as I mentioned before, to the power of t. So let's go ahead and solve this. We divide both sides by 7,500. Okay, so we get 4 over 15 equals 0.85 to the power of t. So now we have a exponential where our unknown is our variable. That means we're going to solve it by converting to logarithm. So we get log of 0.85 as my base, 4 over 15 as my argument, equals t. Okay, so for the old school calculators, log of 4 over 15 divided by log of 0.85. And that will give me my answer, 8.13 years. Okay, make sure when there's context of the question that we always include units. Lovely. Let's move to our last example. Our last example is a regression equation. Remember that there are regression equations in most of the function units. So in this example, I'm also going to go through the other types just so we are familiar with those as well. So example 11 says a researcher discovered mold growing in a petri dish in her laboratory. When first observed, the mold only covered 3% of the dish's surface. Every 24 hours, the surface area of the mold doubles in size, as shown in the table below. So we can see this table, however, the table is not complete. So question A says complete the table and then write an exponential function to model the growth of the mold over time. Okay, so we have 3, 6. Next one, when it doubles, is going to be 12, and then doubling that is going to be 24. We are now going to take this and put it into our stat editor. So you're going to press Stat, you're going to press Edit. And then in L1, you are going to put the first column, 0, 24, 48, 72. Okay, 3, 6, 12, 24. So that's L2 for the area covered. So remember, X is going to come first and Y is going to come second when it creates the equation as well. So just to review, you can also see what this looks like when it's plotted in case you were not told it's an exponential function. So you go second function stat plot, and you're going to want to turn stat plot on. After that, you're going to press zoom 9. Zoom 9, you can see those plotted points, and you can see them start to grow exponentially. That helps you choose which calc to do. So now you're going to do stat, you're going to go over to calc, and then let's just review some of these. So we have the first one you will see, which is a linear regression. Linear regression, quadratic regression, and cubic regression were all part of the polynomials unit, so you need to be familiar with all three of those. Then if you go down to number 9 is LN regression. This is the one that you're going to use if it's a logarithmic regression. Here's my exponential. This is the one I'm going to do. The other one that we also did was a sine regression. So make sure you're familiar with all of those and kind of the general shape that they will take. So I'm going to choose exponential regression. If you have an older calculator at this point, you are just going to press vars. If you have this newer calculator, you're going to go down to store regression equation, then you're going to press vars. When you're at press vars, you're going to go over to yvars, you're going to press enter for function and enter for y1, and now you can press calculate. So here is my regression equation. Y equals A. A happens to be 3. And I forgot to give you rounding instructions, so let's go to the nearest hundredth, 1.03 for my B value to the power of X. So remember, anytime you're writing out your regression equation, you have to put the Y equals for full marks. Otherwise, you will start losing marks. So just make sure that you are using Y equals. Okay, so now we are going to use this to answer questions about it. It says use your function to determine the approximate length of time. So time was my X value, so X is my question mark. To the nearest tenth of an hour it will take for the Petri dish to be completely covered with mold. Okay, so completely covered with mold means that the area covered will be 100%. So if we have a Y value, we are going to go to Y, and you are going to put in 100 for your Y value. I'm just going to change up my window settings a little bit. My Y max, I want to be at 100 minimally. And then I'm going to change my X max. I think I'm actually going to have it quite big. Let's try it at 1,000. Okay, maybe I didn't need it quite that big, but I can see my point of intersection, which is great. So now I'm going to press, so I have y2 as 100, and I have y1 as my regression equation from above. So remember that for this, you do not want to use the rounded equation that you made in question A. You want to use the full version. So if you go to y equals, you see all those decimal places, that's what you want. Now you're going to find the intersection between those 2 points. So second calc, 5 for intersection, and then enter, enter, enter. Okay, lovely. X equals 121 rounded to the nearest 10.4. Check my units. My units are hours.